Hello dear students of +1 medical and non-medical respected teachers. Today I am going to start a very important chapter known as rotational motion, and I will cover this chapter in 3 to 4 videos. In this first video I am going to discuss center of mass of a system or a body. So जिन्ना भी विद्यार्थियों ਨੂੰ सेंटर ऑफ मास या रोटेशनल मोशन चैप्टर थोड़ा डिफिकल्ट लगता है, वो मेरी वीडियोस ध्यान नाल एक या दो बारी वाच कर लियो, तो सारिया डाउट्स क्लीयर हो जानिया, ये मेरी गारंटी है। बस जुड़न की लोड़ है विद ओपन माइंड। तो मैं हमेशा कहना होना है साडा माइंड एक पैराशूट की तरह है। पैराशूट उदी काम करती है तो खुली होंगी है, इस करके साडा माइंड भी उदी काम करता है जो खुला होंदा है। सो ओपन माइंड होके लेट अस स्टार्ट सेंटर ऑफ मास। सेंटर ऑफ मास ऑफ टू पार्टिकल सिस्टम। पहला, व्हाट इज सेंटर ऑफ मास? इट इज ए पॉइंट inside or outside the system or body where whole mass is supposed to be concentrated, or this point describes the motion of the body as a whole. In other words, center of mass is a point inside or outside the body or system about which the body or system is balanced. Every system is balanced about its center of mass. So for example, center of mass of a ring will be at the center of the ring. Similarly, center of mass of a uniform disc will be at the center of the uniform disc. Center of mass of a solid sphere will be at the center of the sphere. So this is how we can locate center of mass of the body or system. Now let us discuss center of mass of two particle system first. Suppose we have two particles of masses m1 and m2 at locations r1 vector and r2 vector from origin O. Join m1 and m2. Let a center of mass cm of m1 and m2 lies at this point. Let r, capital RCM, is a fusion vector of center of mass. The center of mass in case of two particle system will lie on the line joining the two masses. If the masses are equal, it will lie at the center. If the masses are of unequal size, it will lie at unequal distances from both the masses. So suppose this is the center of mass lying at the line joining the two masses m1 and m2. Let F12 and F21 be the internal forces which are mutual acting upon the masses m1 and m2. F12 is the force experienced by m1 due to m2. Similarly, F21 is the force experienced by m2 due to m1 by Newton's law of gravitation. Whenever there are two masses, they experience mutual force on one another. Let F1 vector and F2 vector be the two external forces acting upon the masses m1 and m2 respectively. Then total force acting upon a system of two masses m1 and m2 is given by F vector is equal to F1 vector plus F2 vector plus F12 vector plus F21 vector. Since F12 vector is equal to minus F21 vector, therefore this term within the bracket becomes 0. Therefore F vector is equal to F1 vector plus F2 vector. That is, resultant force or total force of the system is equal to sum of the external forces. So F is equal to, by Newton's second law of motion, what is force? Rate of change of linear momentum. So F vector is equal to dp1 by dt plus dp2 by dt, where p1 vector and p2 vector are the momenta of m1 and m2. Taking d by dt common, what is p1? Write p1 as m1 v1 plus d by dt, p2 is equal to m2 v2, because momentum is equal to mass into velocity. Or F is equal to, vector is equal to m1 can be taken outside. This is a constant, not a vector quantity, so it can be taken outside. So m1 dv1 by dt plus m2 dv2 by dt, or vector F is equal to m1. Now this v1, velocity is rate of change of displacement. That is, we can write V1 as dr1 by dt. We can write V2 as dr2 by dt. So F vector will be equal to m1 d by dt dr1 by dt plus m2 d by dt dr2 by dt. Or F vector is equal to m1, it will be d2 r1 by dt plus m2 d2 r2 by dt. Now taking F is equal to d2 by dt common, so we have m1 r1 vector plus m2 r2 vector. Now multiply by m1 plus m2 divided by m1 plus m2, total mass of the system, because m1 plus m2 is not 0. So therefore capital F vector is equal to m1 plus m2 d2 by dt2 m1 r1 vector plus m2 r2 vector upon m1 plus m2, say equation number 1. Now by Newton's second law of motion, if AC m is the acceleration of center of mass, because center of mass describes the motion of the body as a whole. So total external force will also be equal to m total mass, which is supposed to be considered at center of mass, into acceleration of center of mass. So F vector is equal to m. No, acceleration is rate of change of velocity. So d VCM by dt, or F vector is equal to m d by dt. Now VCM can written as drCM by dt. Again, by definition of velocity, rate of change of displacement. So it will be m vector, capital M d2 rCM by dt2. So comparing 1 and 2, we both represent external force. So we have RCM is equal to RCM vector is equal to m1 r1 vector plus m2 r2 vector upon m1 plus. So this gives expression for position vector of center of mass in terms of masses of the particles and position vectors of individual masses. So this was for two particle system. Similarly, if we have n particle system, then in general RCM will be equal to m1 r1 vector plus m2 r2 vector plus so on plus mn rn vector upon m1 vector plus m2 plus so on plus mn total mass. So from this expression we can also write the position vector, position coordinates of the center of mass. Suppose x1 y1 z1 and x2 y2 z2 are the position vectors of masses m1 and m2 in space. Then xcm will be equal to m1 x1 plus m2 x2 plus so on plus mn xn upon m1 plus m2 plus so on mn. Similarly, ycm will be equal to m1 y1 plus m2 y2 plus so on plus mn yn upon m1 plus m2 plus so on mn. Similarly, zcm will be equal to m1 z1 plus m2 z2 plus so on mn zn upon m1 plus m2 plus so on mn. So we can find coordinates of center of mass if coordinates of individual masses are given in numericals. So this formula is used, very important. Then we come to physical significance of center of mass. What it signifies physically? So from this equation, general equation, so we can write m1 plus m2 plus so on plus mn as capital M. So we have m into RCM. M into RCM is equal to m1 r1 vector plus m2 r2 vector plus so on plus mn rn vector. Now differentiating both sides with respect to t, we have m drCm by dt is equal to m1 dr1 by dt plus m2 dr2 by dt plus so on plus m2 mn drn by dt. What is drCm by dt? Nothing but velocity of center of mass. So m vcm dr1 by dt v1 dr2 by dt v2 drn by dt vn. So m into vcm is equal to m1 v1 plus m2 v2 plus so on plus mn vn. Nothing but v1 vector plus v2 vector plus so on pn vector, because mass into velocity is nothing but momentum. So therefore, what is this? This is momentum of center of mass, and these are the momenta of individual masses. So it means total momentum of center of mass is equal to the sum of the vector sum of the individual momenta. Vector sum of the individual momenta. If velocity of center mass is constant, m is constant, so it means p1 vector plus p2 vector plus so on pn vector is constant. So it's law of conservation of momentum. Then m dvcm by dt. Differentiate further, it will dp1 by dt plus dp2 by dt plus so on dpn by dt. It will be m acm, acceleration of center of mass, F1 vector plus F2 vector plus so on Fn vector, because force is equal to rate of change of momentum. So this shows that total force acting upon the center of mass or resultant force acting upon the center of mass is equal to sum of the vector sum of the external forces acting upon individual masses. So if total force F is equal to F1 plus F2 plus so on Fn is equal to 0, that is, if no external force is acting upon a system, then MACM will be 0. It means MD by dt VCM will be 0. As M is not 0, it means dVCM by dt is 0. If derivative of a quantity is 0, that quantity is constant. So differentiation of d by dt of VCM is 0, it means VCM is constant. So very important fact that velocity of center of mass is always constant when there is no external force acting upon the system or body. For example, when a bomb explodes on the ground, what happens? Different fragments move in different directions, in all possible directions. Why? Because before explosion, velocity of center of mass of bomb was 0. It was at rest. After explosion, different fragments move in different directions. So that center of mass velocity again remains 0. So it means velocity of center of mass is constant because explosion takes place only to internal forces. There is no external force which moves the bomb itself in particular direction. So different fragments move in different directions, so that resultant velocity becomes 0 as it was before explosion. Second example, take when a bomb explodes in the sky. So different fragments, they follow their own parabolic paths, different parabolic paths, but the center of mass follows same parabolic path and falls on the ground. This again proves that velocity of center of mass remains constant. Similarly, rotation of our Earth-Moon system about the Sun in an elliptical orbit also proves this, because both Earth and Moon are revolving about their center of mass. The center of mass lies on line joining the center of Earth and center of Moon, because mass of Moon is very small as compared to Earth. So center of mass of Earth-Moon system lies very close to center of Earth, but both are revolving about their center of mass. That's why they are always diametrically opposite to the center of mass. Earth and Moon are always diametrically opposite to the center of mass, and the center of mass revolves around the Sun in an elliptical orbit with Sun at one of its foci. So these examples illustrate the center of mass. So this is all about center of mass. In the next video, I will discuss torque, which is again very, very important topic. Torque of a single particle, torque acting upon rigid body, and angular momentum, etc. So be happy, stay tuned, subscribe my channel and watch my videos free of cost at home. No need to spend any money in any academy or going to tuition teacher. So all the best, be happy, good luck.